All right, let's do a think, pair, share. Again, this is one that you should try on your own and then come back and watch my instruction. So this is on the effectiveness of hypnotism to reduce pain. A study was conducted to investigate the effectiveness of hypnotism in reducing pain. Results for randomly selected subjects are shown in the table below. A lower score indicates less pain. So what you can see here is that the before value is matched with an after value, and then the differences will be calculated. So here we have subject A, so this is person A, and then this is their pain score before hypnotism and after hypnotism. This is subject B, so person B, their pain before hypnotism, their pain after hypnotism. So we'll be doing a difference of the before and after. Okay, so are the sensory measurements on average lower after hypnotism? So are the sensory measurements on average lower after hypnotism? Okay, so it's not, kind of pointed out, okay, but we have this word after. So is the, put in our givens here. So is the after score lower than the before score? Okay. So what we want to look at is maybe the mean of the after score being less than the mean of the before score. Now let's do a little bit of algebra. So we have it in this form. Okay, that's our original claim. Okay, we'll need this for the Texas Instruments, all right? So let's do a little bit of algebra. Let's subtract mu b from both sides. So this is going to be 0. So we have mu a minus mu b is less than 0. That's our original claim. Now what's going to make this maybe a little trickier to keep track of here is that typically, we put like these values in list 1 and these values in list 2. So we're just going to have to be careful that we do list 2 minus list 1 on the Texas Instruments calculator. And with the NumWorks calculator, we're going to put this in V1 and V2. So we want to make sure that we do V2 minus V1 when it comes time to do that. Usually, I have the first random variable being subtracted by the second. But, here we'll just pay attention to the order that we subtract and we should be okay. All right. So when we do this subtraction, then we're going to get a mean of these differences that we would expect to be less than 0. All right. All right. So let's see, what else do we know? What else was given here? The population standard deviation is unknown, so this means we have to use the student's t-distribution. And so in order to do that, we need to know degrees of freedom, which is going to be n minus 1. Now our sample size, let's see, we've got 2, 4, 6, 8. We have a sample size of 8, which means we're going to have degrees of freedom of 8 minus 1, which will be 7. We're testing to a 5% significance level. So significance is 0.05. Confidence level is 0.95. All right, let's go ahead and proceed to the next step, which is step 2. And this is to set up our null and alternate hypotheses. So we have one hypothesis, which was mu d is less than 0. That is our original claim. And then the complement of that is going to be mu d greater than or equal to 0. And so because as equals, that's our null, that's our alternate. And let me scroll down a little bit. There we go. This less than looks like an arrow pointing to the left, so we're going to be dealing with a left-tailed distribution. Okay, step 3 is now to calculate our t-test statistic and our p-value. So for that, we're going to need a 1 sample mean t-test to do that. All right, so in order to do this 1 sample mean t-test, we're going to have to calculate our differences. All right, so here I've already gone into the Texas Instruments. So list 1 is the before, list 2 is the after. So the differences are going to go here in list 3. Okay, but remember, in order for all of this to work out right, we're doing the mean of the after minus the mean of the before scores. So this will be list 2 minus list 1. We have to do it in that order. So I've got list 3 selected at the top. Column heading is selected. So I'm going to do shift 2 for L2 minus shift 1 for L1 and hit enter. All right. So that's our list of differences. That's an L3. Let's go over to NumWorks. Okay, so V1 is our list of before. V2 is our list of after. So we need to likewise do V2 minus V1. Oops. Come down over here for value 3. So I'm going to click OK, fill with formula, and I'll just make it empty. So now I want to do shift alpha divide, which will give me a V2 minus shift alpha V1. And you can see I'm getting all the same values that I got on the Texas Instruments calculator. So that's good. Both are saying the same thing. All right, now we need to do a hypothesis test for 1 sample mean with a t-test. So Texas Instruments, I'll click on Stat, go to Tests, and I'm going to do a t-test here. Click Enter. It's going to be based off of data. All right, so this mu naught value, this is the value of 0 because we're doing less than 0. List 3 has my list of differences, and my alternate hypothesis was mu d less than 0. Let me corroborate that a little bit. Yes, mu d less than 0. So that looks good. So I'm going to leave that up. Let's go to the NumWorks calculator. Let me click on Home. And then I want to go to Inference. Now I may have to backtrack here. Let me see. Yes, I do. Okay, so let me backtrack to the beginning. Okay, so if I click on Inference, I want to go to Tests, 1 mean, and then t-test. All right, so the null is mu equals 0. The alternate is mu d, so the mean of the differences is less than 0. So that looks right. I'm going to input a data set. Okay, and the data set I want is data set V3, which has my differences. And you can see them right here. So to continue, I need to scroll all the way down to the bottom. Significance level was 0.05, and I'll click Next. All right, so this is giving me my X bar, S, sample size, and there's my test statistic and my p-value, as well as the degrees of freedom. And on the Texas Instruments, let me hit Calculate. And you can see we're getting the exact same values there. All right, so let's go ahead and write these down. So we're getting a t-test statistic of negative, what was that? Negative 304. Oops. So negative 3.04 with a p-value of 0.0095. 0.0095. Okay, and the degrees of freedom, were what we expected it to be. All right, let's move on to step 4. So this is to set up our distribution and calculate our t critical value. And let's go ahead and rewrite our test statistic here at the top and our p-value. All right. Scroll down a little bit. Oops. There we go. Okay, so we've got a student's t distribution. So 0 will be at the center. And let's see, what tailed was this? This is going to be left-tailed. So that means we're going to have a negative t critical value. Here's my significance level, confidence level. It's 95%. We reject the null over the tail, over the significance level. Fail to reject everywhere else. All right, so to calculate this critical value, we're going to need an inverse distribution function. So we need inverse t. So let's go to our distribution functions. We'll go to inverse t. And we want an area of 0.05, but the degrees of freedom is 7. Hit paste. Okay, negative 1.895. Negative 1.895. Let's just go ahead and also calculate that with the numworks. So I'm going to click Home. We want to go to the Distributions app. And so let me go ahead and back up. Okay, students T is what we want. We have 7 degrees of freedom. We want the area to the left with an area of 0.05. Negative 1.895. Okay. Negative 1.895. Looks good. So now let's go ahead and put our test data in. So we have a test statistic of negative 3.04. So that's going to be further out this way. So I'm just going to put it here. So this is our t test statistic. This is where our sample data falls. And if we trace this up, that's clearly in the reject the null region. The area adjacent to the test statistic is our p-value. and that was 0.0095. Comparing apples to apples, we're clearly in the reject null area or region. And if we compare area to area, oranges to oranges, remember, if the p-value is smaller, reject the null. And so 0.0095, this area is a smaller area than the significance level, which is all of that. So both are telling us the same thing, that we want to reject the null. So step 5 is to look at our results and write a conclusion. So we are going to reject the null, and I believe the alternate hypothesis was our original claim. Okay, so let's go ahead and scroll down. So we're going to reject the null. The alternate was our original claim. So where those two meet, that's going to be our conclusion. So there is sufficient evidence to support the claim that hypnotism significantly reduces pain with a 95% confidence level. Oops. And that is our conclusion. Okay. So again, just so much of this was like a repeat, just doing the hypothesis test. The tricky part, again, I think, is translating what our claim is and really kind of thinking that out, translating it to an algebraic inequality and keeping that inequality straight and also keeping straight, what list we're subtracting from the other list, because this will make our differences either positive or negative in the right or the wrong way. So that has to be kept straight. And it helps if you write this all down. But the rest of the process was the same. Okay. Just going to take a lot of practice. Okay. Let me know if you have any questions.